Find the sum to n terms of the following series. Let us begin. So here we have a series with first term being 4, followed by 6, then we have 9, next is 13, and then we have 18, and we have the rest of the terms. Now this particular series is not an arithmetic series because it does not have any common difference. Also, it's not a geometric series because it does not have any common ratios. However, for this particular series, we can observe a pattern. Let's say if we take the second term of the series, which is 6, and from it subtract the first term, that's going to leave us with a difference of 2. Taking the third term and subtracting the second term from it leaves us with a difference of 3. 13 minus 9, that's the fourth term minus the third term, leaves us with 4. Then we have 18 minus 13. This leaves us with a difference of 5. Now we will observe that 2, 3, 4, 5. Clearly, these terms are going to be in arithmetic progression because it has a fixed common difference. So here this is the method that we'll do. We'll use the method of difference to find out the sum to n terms. For this, we will assume that let the series be denoted by Sn, where Sn simply represents the sum to n terms. And we will be considering the last term of the series. We're going to call it Tn. Tn represents the last term of the following series. And we will also consider the second last term. All we have to do is replace this n with n minus 1. Fine. Then what we'll do? We'll consider the same series as n. But this time what we'll do? We'll consider the first term, which is 4, and write it below 6. Then we have the next term, which is 6, but we're going to write it below 9. Then we have 9, we have 13. This keeps on continuing till we reach Tn minus 1 and Tn. What we'll do now, we're going to perform a subtraction. We're going to take the difference of the two series. So on the left hand side, Sn minus Sn, that's simply going to give us 0. Next, we have 4 added to. So 6 minus 4, that's going to be 2. 9 minus 6, that's 3. 13 minus 9, that's 4. 18 minus 13, that's 5. And this goes on. Then till we get Tn minus 1 minus Tn. Okay, we'll transpose this Tn to the left hand side, and that gives us Tn equals to 4 added to 2 plus 3 plus 4, going all the way up to Tn minus 1. Now what we'll do? We'll consider the second term all the way up to the last term, and clearly this is an arithmetic series. The arithmetic series having the first term a equals to 2, the common difference d equals to 1, and how many terms are there? So there will be a total of n minus 1 number of terms. So let's try to understand why there are only n minus 1 number of terms and not n number of terms. So if we consider the first sum, here we excluded the first term, and we considered the second term all the way up to the last term. By definition, Sn has n number of terms. If we exclude any one term, it's going to be left with n minus 1 number of terms. For the second sum, we considered the first term all the way up to the second last term and excluded the last term. So here also, we will be left with n minus 1 number of terms. Now during subtraction, we took n minus 1 terms of the first sum and subtracted n minus 1 terms of the second sum. So we'll be left with n minus 1 number of terms. Okay, so Tn will be equals to 4 added to. So this is simply going to be an arithmetic sum, and we know that arithmetic sum Sn is defined as n over 2. That's the total number of terms divided by 2 multiplied to 2 times the first term added to n minus 1 times the common difference d. Okay, now our number of terms, that's n minus 1. So we have n minus 1 divided by 2. So this is going to get multiplied to 2 times the first term. So that's 4 added to. Now we have number of terms, which is n minus 1. Also, we need to subtract 1 from it, leaving us with n minus 2. Multiplied to the common difference, which is 1. So let's further simplify. We have 4 added to n minus 1 divided by 2 multiplied to n added to 2. Now we're going to combine them. So we have a common denominator of 2. Then we have 8 added to n minus 1 multiplied to n plus 2, which is going to give us, we have n squared, and then we have positive n plus 6 divided by 2. So this is going to be the nth term of the series. So we now have the nth term of the series. We are now ready to obtain the sum up to n terms. So here, to find out the sum up to n terms of the original series, all we have to do is take the summation of the nth term, but what we'll do here, we'll replace the index n with k, such that k runs from 1 to n. Or in other words, all we have to do is take the summation of k squared plus k plus 6 whole divided by 2. So that we have k running from 1 to n. We'll now try to find out the summation, but before that, let's simplify it. We get half multiplied to summation of k squared. K runs from 1 to n. Added to 1/2 times summation of k, where k goes from 1 to n. And then added to it will be 6 over 2 multiplied to the summation of 1 with k running from, again, 1 to n. Okay, now what is summation of k squared? Summation of k squared with k going from 1 to n, this represents the sum of the squares of the first n natural numbers. That means 1 squared plus 2 squared plus 3 squared added all the way up to square of the last n term, n squared. And we have a standard formula for it, that's given by n times n plus 1 multiplied to 2n plus 1 whole divided by 6. Okay, now for the second sum, we have summation of k with k going from 1 to n. So here, this simply represents the sum of the first n natural numbers. Now, sum of the first n natural numbers, that's given by n multiplied to n plus 1 whole divided by 2. And then finally, we have summation of 1 with k running from 1 to n. So this simply means we have 1 added to itself to n number of terms, which in other words means we have 1 multiplied to n, which gives us n. So let's use all of these values. So for the first sum, we are going to get n multiplied to n plus 1 multiplied to 2n plus 1. Now what we have here, divided by 6, but we also have to multiply with this half. So that's going to give us 12 in the denominator. Added to n multiplied to n plus 1 divided by 2. So we are going to multiply it with 1/2 to get 4 in the denominator. Then we have 6 over 2, that's simply 3. So we have 3 times summation of 1, that's going to be n. Okay, now this is going to be our sum. What we'll do, we're going to combine these 3 terms. So we have a common denominator of 12 here. So in the numerator, we start with the first term. So that's n times n plus 1 multiplied to 2n plus 1. Added to the next term. So that's going to be 3 times n multiplied to n plus 1. Added to, we have 36n. Okay, let's further simplify. What we'll do, we'll take n as the common factor from each of the terms. We have n over 12. This is now going to get multiplied with, so n plus 1 multiplied to 2n plus 1. So that's going to give us 2n squared plus 3n plus 1. Added to, now we have already pulled out n from the second term. So we have 3n added to 3 plus 36. So this is going to be equals to n over 12 multiplied to 2 times n squared added to, so 3n plus 3n, that's going to be 6n added to, so 36 plus 3, that's 39, 31 added to 1, that's going to be 40. Now what we can do, all of these terms inside the parentheses are factors of 2, so we can factor out 2 from each of the terms, and that's going to leave us with n over 6 multiplied to n squared plus 3n plus 20. So therefore, we have finally obtained the sum to n terms of the series, which is given by n over 6 times n squared plus 3n plus 20.